Hello, and welcome to the IPA Institute webinar series. My name is Andrew Griffith, and I'm the director of the IPA Institute. The IPA Institute is a group within IPA, or Independent Project Analysis, that is focused on taking all of our research and learnings from our benchmarking and compiling them into focused training seminars as a way to help communicate our research more deeply into the organizations and carry our work and observations from capital projects to a wider audience. So today in this webinar, we are presenting one of the modules from one of our core courses. The course is entitled Project Management Best Practices. And I will be delivering one module focused on project controls, or the best practices for project controls. This is simply one module out of the entire course, and our objective is to give those of you who download this webinar an opportunity to see an example of what the course design is like and flow and the type of material we cover in the course. So with that, I just want to kick it off and take you through this one example module. The learning outcomes for this particular module are highlighted here on the slide. First of all, we want to simply define project controls. We want to lay out what it is and the construct around it, particularly in the context of capital projects. And then we want to spend some time listing and going through some of the best practices for project controls that our research has shown correlate or help explain project outcomes. Fundamentally, the application of these practices in our database show a correlation with either more predictive capital projects or more competitive capital project results. So the objective of this module is to lay those out for you in a way that can easily be incorporated into your own project system and highlighted as areas for improvement to help improve the overall performance of your capital projects. Now, in this slide, we are showing the modules for the overall course, highlighting the different topics that are discussed in the course, and working down through it. This particular module on project controls is one of the last modules in the course. And in it, as I said, we'll define project controls. And then the bulk of this module is spent talking about the best practices for project controls that our research has identified that correlate with better outcomes. And then finally, I'll introduce you to a metric tool, a measurement tool, the Project Controls Index. It's one of IPA's fundamental measurements of project systems in terms of our benchmarking analyses. And with this index, it helps us understand how comprehensive, how well developed is an organization's project controls infrastructure and system. So let's kind of kick it off and speak in general terms about project control and project control objectives. Basically, we think of project controls as having two primary objectives. One is the regulation of results, as it says, through alteration of activities. Basically, to put that in plain English, the point of controls is to affect the outcome, to make it better, to mitigate damage from bad events, to actually influence the project. When I speak of it in terms of a project system, often it means making decisions that will improve the outcomes or help limit damage from disruptions or changes. The second element of project control should be the stewardship of organizational assets, meaning tracking, being able to clearly understand and manage and prevent waste of critical organizational assets such as money, obviously, time, and the resources that are used as part of a capital project. One thing to keep in mind, project controls costs money to implement. It's not free. And so there needs to be an upfront investment in project controls, infrastructure, personnel, processes, and systems. But IPA data and research clearly show a strong correlation between the investment in a sound and robust control system and better project performance. So the payback on that investment in a project control system is very high and well worth the investment of conducting and implementing project controls. So in this particular slide, I wanted to touch briefly on two concepts, or the idea of cost engineering as a basis for project control. Cost engineering, as the slide says, and certainly there are a lot of words here that I won't read to you, but basically cost engineering is the act or the skill or the position of cost, schedule, and resource analysis, planning, estimating, forecasting, etc., that is implemented on a project, on a capital project. And the word engineering is designed to reflect that linkage of cost and schedule skills with the technical knowledge of the project. So we're speaking of a more technically focused skill set that works with the cost and schedule and resources. And again, the owner, in the context of our discussion around the owner project system, these owner cost engineers work with design and the construction to help optimize the project to improve its business value. Now, the control practices of cost engineering, as we said earlier, include tracking and monitoring and evaluating these things, these elements, and coming up with the forecasts. And so there is a role of project control that is implemented by cost engineering on capital projects. Now, I wanted to also spend a moment on the distinction between control versus monitoring. Project control can often be confused, somehow mixed up with monitoring. But we like to talk about it in the context that monitoring is passive, whereas control is designed to actually do something, to implement, to affect the outcome, as it said earlier in the presentation. When I deliver this to a live audience, quite often I'll use the analogy of monitoring is just watching the train wreck, whereas control is actually trying to affect the process and improve the results, or mitigate the damage from anything that might have changed or disrupted a project. As a result, planning without action is just watching. And when there is no, you cannot have control without some level of authority, or at least a close ear to management to help explain the data and lay out the argument of what needs to be done based on the information from controls processes and the forecast. An overall project control system, as this graph highlights, really involves several different spokes or elements. You have an overall scope control, which clearly is the most leveraging as you begin to experience scope creep. Obviously, that affects the other spokes. But scope control, and as a part of that, obviously, cost control, schedule control, and then finally quality control, all together form a total project control system. So our discussion is primarily focused around a total project control system, but for the most part, we will be focusing on best practices around cost control. Now, to walk us through a fundamental project control process at the highest level, you can lay it out like this. You build a baseline plan, you lay out your plan, you build your schedule and your cost estimate, and you track that actual performance against the plan. Obviously, that requires an infrastructure for collecting data on the actual performance, a mechanism in your data collection to compare or analyze the data in comparison with the plan. So that would imply your data collection is designed in a way that matches your plan. And when you observe variances, to document them and use the data to forecast the likely final outcome, whether the cost outcome or the schedule outcome. And the next step in this process, obviously, is to inform stakeholders of the changes, help them understand the variances, help them understand the changes in the forecast and what can be done about it, and to understand the whys of those variances. What has driven it? Have the price of materials gone up? Has labor productivity not been as good as expected? Are we experiencing scope creep, which is actually modifying the base plan by introducing additional elements? And once you've made those adjustments based on forecasts and trends, based on what's possible and what are your business priorities, you may accelerate procurement if the schedule is a concern, but recognizing the cost impact of that. And then finally, feeding the results of this back into your system to improve future projects. So at the conclusion of a project, one of the most important steps that we'll highlight later is to feed the actual cost and schedule results back into your project system so that you are able to improve your future projects, estimating, planning, and scheduling. So that was meant to be just a very high-level, brief introduction to project controls as a way to begin this next discussion around project control best practices based on our research. Now, I want to emphasize, IPA has identified this set of owner project control practices that our data clearly show drive improved project outcomes. But they are not meant to be a comprehensive, complete control process or system. What we have identified are practices that add value, and when we observe them in an organization or its system, reflect real owner commitment to project control. And again, our whole perspective is from the point of view of a capital project owner that is in the process of working perhaps with multiple contractors in planning and executing a complex capital project. So if we were to lay out the best practices identified by IPA's research, we've organized them here by project phase. For those of you familiar with IPA, front-end loading being the project definition phase, that initial phase of a project leading up to the full funds authorization or sanction point. Execution, covering engineering, procurement, and construction. And then one of the best practices is a post-project exercise that we'll talk about that is critical to maintaining a healthy and current project control system. So we'll simply walk through each of these briefly as a way to highlight them, show a little bit of data on how they influence, and some of the specifics. But again, the point of this module is not to teach the details of each of these, but to highlight each of them as clear best practices that differentiate project systems in the terms of how thoroughly and comprehensively they implement project controls. So let's talk about the first one. Build an integrated and resource-loaded schedule. Throughout IPA's research, we have spent a great deal of effort collecting sample schedules from each of the projects at the time of authorization and evaluating their level of definition, as well as how well they've been assembled from a technical point of view in terms of scheduling practices. And what we have found is that building an integrated resource-loaded schedule is a practice that is clearly correlated with better outcomes. And by an integrated schedule, we mean one that covers all the critical project phases: definition, detailed engineering, procurement, construction, when applicable, shutdown and turnaround, and in addition, the final commissioning and startup phase. And what this schedule does is it provides a framework for planning the project. It provides a clear communication tool, and it provides a basic model of how the project will be executed. It identifies critical activities, relationships, forces the team to acknowledge constraints that may drive the project schedule duration. As I noted, it's a communication tool. And finally, it's required for any type of earned value or integration with the cost estimate in modeling the execution approach, and building an earned value mechanism. Finally, it pulls that project planning into a single process, into a single model, and becomes the owner's window on the project. So our data, time after time, shows one of the critical elements of a project control system is to build this integrated resource-loaded schedule during the front-end loading process that becomes a basis at the end of front-end loading for the control of the project in execution. The next best practice that we want to focus on is negotiating strong audit rights. Again, from the owner's perspective, audit rights should be obtained for all these three elements: cost reporting, electronic schedule updates, and physical progress. Meaning the owner needs to make sure that their contracts and their agreements put them in a position to be able to look at the details of these three elements of project control that their contractors are working. That means they should be able to get electronic versions of the schedule at their monthly or bi-weekly updates. They should be getting detailed cost reporting, as well as clear measurement process around physical progress to justify the claimed percent completes and progress of a project. And the issue is that they should be well documented in the invitations to bid and can be incorporated for any type of project type. And once these audit rights are established, they must be exercised immediately. We cannot then not collect that information, and then suddenly when the project's facing problems, we would ask for them later. We need to implement that audit privilege from the very beginning, as well as field auditing, in terms of having field representatives from the owner's project control group to be in the field checking fabrication, construction progress, installation, all following the clearly documented cost and schedule reporting procedures. A third element in the front-end loading phase, in terms of a project control best practice, is the process of an owner estimation validation. Quite often, in fact, I would say in a majority of cases, towards the end of front-end loading, the basic estimate, the cost estimate, the bottoms-up authorization grade estimate in terms of quantities and productivity estimates and units is developed by a third party, by a contractor or by a PMC, project management contractor or consultant. And so what we find differentiates project systems are those that do a separate and robust validation of that estimate. Validation, as it states here, provides a quantitative check of the cost estimate. And what we see as a common approach is to be able, as an owner, to compare ratios of different categories with data that the owner has been able to build over the years to understand installation ratios and other ratios that we'll discuss in a moment. The problem is that this process requires estimate data from the contractors in a format that support the validation process. But they also require that we as owners have these data in a format and a granularity that make it possible to do any type of detailed ratio analysis to check and validate the soundness of the cost estimate. Some common sources of data for owners are to compare their actual cost of past projects and the actual ratios of past projects with a prospective project, or compare them with past estimates or check estimates that they have in their archives. And we also see owners use them as comparisons with relative cost metrics or ratios available from their own archives or outside sources. In terms of metrics for validating cost estimates, here's a set of ratio types that we typically see used in this process. Cost to cost, as the name implies, are a ratio of different cost categories to one another. Percent of total cost, for example, engineering as a percent of total cost, or labor as a percent of total cost. We also see a total cost to equipment cost, or commonly called Lang factor, as another metric to check the validity of a cost estimate. The other category of ratios that we see used is a resource to cost ratio, where you may compare field hours to a total project cost, or perhaps field hours to some unit of equipment cost. Finally, third would be a cost to resource ratio, where a very common labor cost over number of hours, or material cost over the quantity of material. For example, material cost of piping to the quantity of that material in terms of linear feet. And then fourth would be a resource to resource ratio, where you might look at craft hours per quantity, number of hours per linear foot, or number of hours per cubic meter. Whatever your units are, those would be the resource to resource type of ratio. And the key is that we would have access to these data in-house or through some other source and make comparisons with our prospective project's cost estimate to check the validity of the bottoms-up estimate provided by a third party. Now, why is it important and how can it be measured, the importance? On the bottom, we're showing a relatively weighted level of robustness in terms of a validation process. 0 being no validation process, 1 being a summary or a limited validation process, and 2 being a much more comprehensive validation process. And what you see in both the red line, which are for fixed price construction contracts, and for the blue line, which is more of a reimbursable type of construction contract type, that the more comprehensive the estimate validation on the owner's side, the more competitive the project. And I want to emphasize, these data, we're holding the front-end loading index. If you're familiar with IPA's front-end loading index, we're holding that constant at industry average. So we're measuring statistically the effect, independent effect, of having a comprehensive estimate validation process as part of your project control system. Now, the fourth area of the front-end loading phase when we talk about project controls, best practices, is to maintain estimator independence. Now, again, as we'll highlight in the slide, the point is that you are setting up a checks and balance process that help ensure a cold eyes type of input into your project estimate and schedule to help limit any opportunity for bias or other errors in the process. And so you want to ensure that your estimators are free of undue bias. Look, as we all know, managers can be biased toward a favorite project, or they may have a predetermined cost or schedule duration in mind. And what we have seen over the years are cases of underestimating because of pressure from the project team or the management to say, well, if you have the cost too high, you'll kill my project. Where what we're concerned about is quite often that price or cost estimate is accurate, and lowballing it with a bias actually sets the project up for disappointment in terms of cost overrun and possibly not meeting the business objectives. And so we've also seen cases on the other side where overestimation of a project cost, because the project system is punitive environment in that any overruns whatsoever are brought with very strong punishment or organizational disincentives. And the end result is the project system runs, 100 projects, and they all underrun their estimate, which also is a bad practice because it is not taking care of capital. It's squandering the capital that would have been available in a more mixed and more balanced type of project system in terms of delivery and performance. Finally, the last element around the front-end loading side of things in terms of project control best practices is estimate for control. Now, too many estimates in our observation are prepared with the objective of determining the number, the final project cost. And the concern then is it's not set up for monitoring and control during the execution phase. As a result, what we find best practice is that cost estimates need to be structured to support project control. That means they must be organized so that all the categories are separate and can function as a basis for control, meaning you followed a good work breakdown structure, a well-established code of accounts that should be established early and cover the entire project scope. And even for fixed price contracts, the owner's estimate can be designed for control and provides the good basis for evaluating the contractor's proposals by breaking down even the owner's estimate pre-submission of bid, and a robust breakdown to break it into different categories provides that fundamental tool for evaluating the contract's proposals and putting them in a position to challenge some areas and understand and surface discussions in other areas. So as a fundamental practice, there's the classic approach of a cost and schedule developed around a work breakdown structure. And again, this is part of that estimating for control, where the concept is to begin with a project scope, and based on that scope, build a work breakdown structure that breaks the project down into successively finer gradations of specific elements or deliverables. And then finally, at the bottom of the WBS, often called work packages, we use those work packages as the basis for building the project schedule and the project cost estimate using the same design or work package breakdown, with the obvious objective that the schedule and the project cost estimate are aligned, perhaps not line by line, but certainly at the work package level. And that way, then, we can implement a robust controls process during execution where we can monitor both the project schedule performance on the work package level and the cost estimate on the work package level. Some of the benefits of a common work breakdown structure: well, they should be designed using that work breakdown structure because they facilitate cash flow analysis and earned value analysis. They help to ensure consistency between the estimate and the schedule, and to make sure that the entire project scope is included in the project. And also, it facilitates resource loading of the schedule. Generally, your cost estimate is where your hours are loaded. You understand your crews and your labor expectations and productivity in your cost estimate. And by having a well-developed WBS that forms as the framework for the estimate and the schedule, it becomes much more transparent to then resource load the schedule to ensure that your schedule expectations will not require a higher level or a larger peak of resources than will be available or than your system can withstand, whether it's by space or availability. So this whole integration and/or a common WBS provides a consistent project controls basis in terms of moving forward through execution. So that was the summary of the elements under the front-end loading portion of project control best practices. Now we're moving into a couple best practices in the execution phase. The first one being proper use of physical progressing. Physical progressing, simply put, is a method to measure completion of the work. It is a mechanism for understanding how far the work has progressed using actual deliverables, actual measurable items, as opposed to simply estimating percents complete, or worse yet, using hours as a measurement of progress. And physical progressing is essential. It's an essential skill that helps maintain the control of our projects. An objective method of physical progressing is reliable and provides a better control. As I had mentioned earlier, tracking cost as a measure of progress is risky. You can spend a large amount of money and actually not accomplish very much, whereas physical quantities or events can be identified and they help you measure your actual progress. And it helps the team to ascertain where gaps exist between the money spent and the actual scope completed. In terms of the basics of physical progressing, some basic steps of it, in the confines of a very brief webinar like this, I'm just going to highlight the 4 basic steps. After you've built your cost estimate and your quantities that are based on that, you assign a weighted value to an activity or a group of activities or deliverables associated with some physical item or event, whether it's installation of foundations in a particular area or completion of piping, or in design, a final review of some step in the process of design. And so you measure the degree of completion of that particular activity by counting the items or quantities or the successful completion of the event. So we have added some sort of weighted value in terms of units of currency, whether it's dollars or euros, and then we measure that percent complete or that completion by counting the number of items. So if we have completed 5,000 linear feet of pipe and the overall estimate is to have 10,000 linear feet of pipe, then we're obviously complete with 50% of the planned installation. And so you determine the overall progress of the project by summing up the achieved or the earned value, meaning the extent to which we've completed installation or delivery of the particular item times their weighted value for each item, and you sum them up over the total expected price or cost of the project as a way to arrive at a percent complete that is based on actual deliverables and is a control mechanism as opposed to using cost or the number of hours used. And so by dividing your earned sum by the total value, you determine a weighted quantitative-based percent complete. Now, certainly not every item must be weighted and measured in physical progress. I mean, in a major capital project, you can certainly have some level of aggregation or groups of some items as a way to reduce the paperwork and tracking cost. But the estimated quantity and weighted value needs to be accurate and up to date. And ideally, you would not have anyone biased involved in the process who would be responsible for measuring that progress. Depending on the region of the world you're in, obviously some use quantity surveyors in this process, and others may follow a different mechanism than staffing to get this done. So even at authorization, at the end of front-end loading, the estimate needs to be structured to support and set the project up for physical progress. And this is one of the critical measures that we gauge as part of a project evaluation, is an understanding of the extent to which physical progressing is designed into the cost estimate and the project controls plan, both for the engineering deliverables as well as the construction deliverables. And it's important when we simply gauge the level of physical progressing on a project at authorization or the planned physical progressing in one of 2 or 3 categories: no physical progressing, some physical progressing but not comprehensive, and then finally, yes, very strong physical progressing. We see a significant jump in performance from the no progressing to at least some level of physical progressing. Here on the vertical axis, you see execution schedule predictability, 20% being the average for projects with no physical progress. And that is to say, on average, those projects experience a 20% schedule slip from the time of authorization to the actual completion. And so what's interesting is that even with some level of physical progressing implemented into the project system is correlated with a significant improvement in schedule predictability, all the way from about a 20% average schedule slip to what looks to be maybe a 7 or 8% schedule slip, as well as a more narrow bandwidth for that particular group of projects. And you can even, ideally, we would still do this for lump sum contracts. It's as important as it is for reimbursable projects. This tracking allows the owner to recognize when a contractor's performance is suboptimal or late or behind schedule, so they can take remedial action. In addition, the owner's payments to contractors should be based on work progress, physical tracking of that work, to ensure that the owner's payments are not getting out ahead of the actual work. Certainly, the owner is not able to track contractors' cost in lump sum contracts, but they should be able to view, particularly in engineering, some details around the hours that the contractor uses. And this would help gain some insight into the overall cost performance of the contractor. The second category in the execution phase in terms of best practices for project controls involves the frequency and detail of project status reporting and how that correlates with better outcomes. Basically, the practice shows, or the research from IPA shows, that frequent and detailed progress reporting is correlated with better outcomes. Now, obviously, that frequency and detail is dependent on the size of the project and other factors, but basically what we're seeing when we look at across the industry is that frequent and detailed reporting is another indication of a good project control systems. And these reports require that all the pieces of a control system are in place. So it needs to have been estimated for control. There needs to be a physical progressing mechanism in place, good schedules at the beginning that serve as a basis for schedule control and forecasting. Obviously, this report can be prepared by contractors, and that is not at all a disconnect from best practice. But the owner must be the one to establish the reporting requirements and frequency and the information that must be included in these reports. And they must then evaluate and react appropriately to the report contents. The owner must be in a position to digest the reports fully and take those results and act on them based on the learnings from the reports. Again, a little bit of data from IPA's research in terms of the projects that had no reports compared to projects that had a monthly reporting system, with a set of projects that had more frequent reporting system. And we see that the execution schedule effectiveness, and again, 1.0 in IPA's indexing process indicates industry average based on a statistical benchmarking methodology. You can see that projects that systematically don't have reports, or infrequent or superficial reports, on average are slower than the industry average, and there's a wide variation. Some of the very worst performing projects are in this population in terms of a schedule performance of 1.4 or greater. Whereas project systems that do a report on a monthly basis, and even more so on a bi-weekly basis, have improved schedule performance and, to an extent, more narrow division. The statistic of on the right side of the graph shows how the correlation is a very strong statistical correlation with a probability of significantly less than any threshold of statistical significance. But what I want to emphasize is these reports, we're not talking about the glossy, pictured monthly reports that may go up to a public consumption or to the top management, but that these reports are downloads of the project data compiled into a useful data-rich format that are then available to the project management and leadership for quantifying where the project is, where are the variances, what has changed since the last status update. So its level of detail and the amount of information and the frequency that these are made available. I liken it to how frequently an airplane's altimeter and other instrument panel are updating the information. You're looking for that information to be accurate and updated very frequently to be able to understand where the flight is and the conditions under which the plane is flying. Now, how does it accelerate execution schedules? How does it affect a faster project's result? They're a tool for keeping on schedule by showing schedule variations on a very timely basis, frequent basis. Without that frequent reporting, any delays in the project may go unnoticed by the project system. And so the schedule benefit is strongest on these reimbursable projects, because obviously the reimbursable is where the contracting strategy places the cost risk of schedule delays on the owner, as we spell out here. So it is the frequent reporting under a reimbursable contract basis that shows the strongest correlation with better outcome performance. Then finally, the last best practice in our suite of project controls best practices is focused on developing and maintaining an owner's historical cost schedule database. And our observations is many organizations find this to be one of the most difficult elements of project controls. Why do we advocate keeping a historical database? Well, the owner just simply is responsible for their projects. They cannot abdicate that responsibility. And coming up with the cost and the schedule for that particular owner to do that project is one of their responsibilities. And this database is used by the cost specialists or the cost engineers in that validation process that we spoke of at the very beginning. Without this database, any form of robust validation is much more difficult. You're relying on outside data or data from third parties that you really are not sure how accurately they reflect your company's performance as a mechanism for measuring that cost estimate accuracy. And one of the keys of this process of a good project control system is that the project manager and cost specialists with each team take on the responsibility to contribute back to the database. That means closing out the project, completing all of the cost reports, getting all the detailed information, and compiling it into the right format that it can be incorporated into the project's documentation and data system. And the key is that you communicate to the contractor the format that this must be done so that it can be uniformly collected and updated into the project system in a clear way to maintain competitiveness. Why is it important? Well, when we look at two populations, one where there is an owner-employee focused on data collection, data archiving, maintaining a historical database, and one where the other companies where the owner does not have an employee focused on data, we simply see a much better cost performance from the organizations that have a data focus in terms of archiving historical data and using them as a robust process for cost estimate and schedule validation. So, having admittedly quickly, walked through the fundamental best practices as identified by our research, I wanted to finish off this discussion by introducing you to our project control index. Basically, we have taken these best practices and compiled a simple indexing system that we use to benchmark project systems and benchmark them around their infrastructure and design for project controls. It's a measure of an owner project control practices at a very high level, touching on four key practices: the estimate validation by in-house estimating, the extent to which physical progressing is used, the level of detail and frequency of status reports, and then finally, at the most fundamental level, does the owner have a project controls specialist assigned to the project? And obviously, for very large projects, we're asking about a owner's project controls specialist team of both cost and schedule specialists. And we've taken this rather simple construct and created a single measurement using a single combination of these particular practices. And the PCI, the Project Controls Index, measures those four project control best practices in the fundamental construct shown in this graph. Estimating for control, and we're looking at in-house cost specialists validating the estimate, and control during execution around physical progressing, the frequency of reports, and the extent to which there's an in-house project controls person or team assigned during execution. So again, the PCI is a very straightforward measurement system based on a single scale, and it correlates strongly, independently, and strongly with project outcomes. And I want to emphasize this note in the bottom. This PCI is in no way constituting or proposes to be a complete project control process. It's simply a proxy measure of the strong project control process, or the extent to which an organization or project has a strong process in place. When we look across the data in terms of both large and small projects, we see a small shift, or a shift around small project systems. As you can see, the industry average for large projects and the industry average for small projects with best practical front-end loading index. And remember, if you've not dealt with IPA in previous work, our front-end loading index is the measure of level of definition at the time of authorization. You can see that large projects, as a general rule, have a better level of project controls than do small projects. But as you can also see, that there's a large difference between the industry average for large projects and the industry average for large projects with best practical FEL. What that indicates is there's a strong correlation between the good practice of front-end loading and the good practice of establishing and setting your project up with a strong, comprehensive project control system. Now, when we look at the project controls index and gauge that against schedule performance using IPA schedule effectiveness index, we can see that there is a strong correlation between the project controls index, using this descriptive terms for each of the levels of quality on our PCI, good, fair, poor, and deficient, and the schedule performance. Projects that systematically reach a good level of project controls are more likely to be faster than industry average in terms of their execution schedule, whereas projects that are in fair or particularly poor areas of project controls systematically seem to result in longer or slower than industry average schedule performance. Now, when we look at this in terms of slip, we see a strong correlation, particularly for reimbursable construction, meaning that projects under a reimbursable format with good project controls index values systematically come in very predictable or even slightly underrun their target schedules. Whereas projects with poor levels of project controls, as measured by the PCI, systematically are turning in projects that are 10 to 20% in terms of slip from their target schedule at the time of authorization. And we see this more with reimbursable projects than with lump sum type of projects, obviously because under a reimbursable, the owner is responsible and is liable for cost overruns resulting from schedule slip. So a more robust project controls index is a clear predictor of more predictable schedules under this contracting format. Now, in terms of a contingency used, we also see that under both reimbursable and fixed, there is a strong correlation between the project controls index and the amount of contingency actually used. And when I say the amount of contingency actually used, I'm saying the delta between the base estimate with no contingency and the final total project cost, reflecting how much contingency was actually consumed in completing the project. And they both correlate strongly with better levels of PCI. Better levels of PCI, or Project Controls Index, is associated with a lower use of contingency. But obviously, there's an offset between the reimbursable construction and fixed price construction, driven by the nature of the project, and that the fixed price, the contractor has obviously incorporated some contingency into their lump sum bid, which is not reflected under a reimbursable construction format. So in wrapping this up, project controls is a good investment when we look at the data across the industry. As part of our cost collection process and our cost estimate evaluation, we collect information about the amount of money invested in the project control function. Now, there's a wide range in that estimate. It can range from as little as 0.5% to as much as 3% of the total project cost, depending on the accounting structure and how those monies are allocated. But in terms of improvement, both in predictability for cost and schedule and the absolute cost competitiveness, we can see best practices driving an improvement from 6 to 20%. 20% being an extreme, obviously, but still there's a significant improvement in performance of these projects that apply a more robust project control system. So basically, the internal rate of return, or the payback on having a robust project control system, as well as the overall benefits to the project schedule and cost, is significant and well worth the investment of developing and implementing a strong project controls mechanism as reflected by the best practices we've just discussed. So in conclusion, this particular discussion was designed to present an overview of project controls best practices as identified by IPA research, and to simply touch on each of these practices briefly and highlight some of the data from IPA's research that supports the relationship between the use of these practices and better outcomes. But again, it's not intended to lay out in 1 hour a comprehensive project control system and infrastructure, but highlight the key touch points that serve as a proxy for an owner organization and their infrastructure for project controls and an overall capital project system. So I want to thank you for your time and listening and viewing this webinar. And if you have any questions, by all means, we will provide some contact information as well as follow up any questions that you might have in regard to this presentation or any of our other discussions that we are posting as part of the IPA Institute webinar series. Again, thank you for your time, and I look forward to hearing from you. Thank you.